Hello, everybody. I hope your week is going well. We are doing lab today, and we're going to have a walkthrough, although a quicker walkthrough of the correlations that we have been learning about. So the Pearson R, the Spearman Rho, and the point biserial. There are a couple things just to mention. One, your exam grades and the homework grades. I'm just waiting until I can have everything graded until I put it up online, but that'll be really quickly at this point. One thing did occur with the last exam, and that is that one of you did not write dark enough. So when we tried to scan it, and we tried it on several different scanners, it did not transfer. So at least for one of you, what we're ending up doing is having to mail it to me. So there will be a delay in terms of grading for at least one of you, but everyone else I'll sort of take care of quickly. And I'll send an email to the student as well. But as a reminder, these things are being scanned to get sent to me. And we do need you to write dark enough for the scanner to pick it up. So if you're just using it, if you're one of these people who uses a pencil, which I encourage, but you write either really small or really lightly. Our scanner, we've tried 3 scanners and it didn't pick it up on any of them. So I'm gonna have to say it's not a scanner issue, you just wrote way too light. In person, Sammy said it's actually readable. She can see what's supposed to be there, but she's not the one grading. So there's gonna be some delay. So just remember that we're doing some stuff to get the stuff or the exams and quizzes and homeworks to me quickly. Please do your bit to help out. So write neatly. Don't cram it all into the corners of the paper like some of you still do. And it's like I'm going to save paper and make it completely unreadable. All of those things. Someone has to grade this, and I need space if there is a problem to write some comments about here's where it went wrong, here's what to do it. If you have everything crammed into that paper, and there's no space for anything, I may not find what I need to find, and I may not be able to leave you a comment. So make sure that this is a place that I can actually give feedback if feedback is necessary. Okay, so there's one mistake in terms of how I presented this today, and it comes in the fact that I asked you to have the data sets ready, or to at least have downloaded them. And it took me off at the knees, and you'll see why in just a second, of something I was trying to do. But I hope the problem is, at least you understand what I was trying, and we will go from there. I have like this. These lights are sort of weird today. Okay. All right. So let's just show the first one, and you'll see where things went wrong. So the idea here, let me get this out of the way. The idea of this was that I would give you a setup, and the first step would be picking out the right formula. Remember, I said that is part of what this particular one is attempting to do. We're at this phase after exam 1. There are 3 correlations. Knowing which is the correct formula, knowing which is the correct data set to formula is going to be important. What I didn't realize is I did give you the data sets, and it says at the top of them what analysis it is. So my attempt to have you guess what this one was, I'll at least walk you through it. It's not going to have the payoff I was expecting because everything is labeled. But that's a lesson learned, and we'll sort of just go with it. Here's what, again, a homework problem would look like, what an exam problem would look like, and what the data set that goes along with it would be. So this would, in essence, be this is what you're given, and your task is to solve this. Again, one other thing I guess I should mention, it'll become very obvious in a bit. I'm not going to go through sort of as beleagueredly as I did last time. So for on the day where I walked you through every single component and talked about them at each step by step, it will be, solve this portion, and then check the next slide and it's all done. So we're not going to sort of take it apart multiple times. Each step is going to be on a different slide. Just pause and you do your work and then check the answer. And then hopefully we're going to have at least one video this semester that is under an hour short. That would be lovely to have. Okay, problem 1. There's an allegation made at this widget factory that there's some unfair work practices in place, specifically at the part-time level. The females earn less than the male counterparts do. I get access to the results of paychecks and hours worked for about 80% of the workers in a given week. And I'm asked to do a correlation between gender male and female, and the number of hours worked to see if there is a relationship between gender and hours made available. And then your instructions: conduct the correlation and interpret the finding. And that's how this is set up. That's all the information you need to sort of go forward. And you have the data itself over on the side, or at least the part of the data that is over here now. Okay, that's it. So what would your first step be? Well, the first step would be, what kind of analysis am I doing? And again, it's sort of, the mystery is taken away by the spoiler at the top of the data page. If you just match this up with the data, you know which one you're supposed to be doing. But let me walk you through which one you're supposed to be doing. So this actually should be a point by serial. Our first data column is a nominal category, so male and female. Ones I have set up as male, two set up as female. And then in the Y column, the actual data, the number of hours that are being shown. Now you can work 0 hours during a week, and that could have been collected. And the hours, difference between 14 hours and 15 is the same from 20 to 21. So we're on a similar scale. So this is interval or ratio data. Again, we don't really need to get more specific than that. As long as it's interval or ratio, as long as we crack interval, the analyses are the same. So one column of nominal, there are two categories, which makes it a dichotomous nominal variable, and one which is interval or ratio. So we know that we're going to be doing a point by serial. We're asked in this case to do a correlation, but it also could have said, what is the relationship between the factors? And that would have also, relationship also indicating correlation. So we do know that this is supposed to be a point by serial. All right, now again, on exam day, homework day, you would have had to figure that out on your own. Okay, hope you could. So here's my snarky little, you do know you're supposed to, yeah. Okay, they're labeled. All right, so step one, of course, would be write the formula down. And what we're going to need to do first is collect the means. And remember, that's the first part of the formula that's there. As always, I assume that the means are within your wheelhouse. So I actually did the first one for you, calculating the means. Hopefully that screen will tick up. So here I wrote the formula down. Mean of group 1 minus mean of group 2 over the standard deviation, multiplied by the square root of P times Q. So I figured this out for you, again, on regular homework or exam. You're going to have to do that first step, but you got that down. Double check it just to make sure you get it correct, but those are the scores that you should get. So the mean score for the female worker is 18.61 hours. The mean score for the male workers is 18.18 hours. So that is step one. Well, what is step two going to be? Well, we just work our way through the formula. So the next step is going to be standard deviation. We've done this. Okay, so here's our formula, point by serial listed. We have the means. Next step is go down and do the standard deviation. So you solve for the sum of squares, take the result of sum of squares, plug it into the standard deviation, solve for standard deviation, and remember our warnings from last time about the standard deviation. Go ahead and solve, and then come back and check to see if you are correct. Okay, so the caution, of course, for this was that you're doing the standard deviation as if this is all one sample. You're not doing separate standard deviations for groups. We're doing it as if it's all one sample. So to do this, we put up our formulas. So calculate the standard deviation. The formulas for sum of squares, remember, it's in the Y column. So you would have had to square each of the values, add them all up, and get the sum for both the Y column and the Y squared column. So you can plug these things into the formulas. Sum of squares is equal to the sum of the Y squares minus sum of Y squared over N. So that meant you had to create this column, and you need to both sum this column and you need to sum the Y column. So all of this work being done is by looking at the formula, knowing that you have to you need this information in order to solve. Okay, so you solve for sum of squares. 8504 minus 442 squared divided by 24, our number of participants. Our sum of squares is equal to 363.833. Take that score, plug it into the standard deviation formula, the square root of sum of squares over n minus 1. 363.833 divided by 23. Take the square root of that, and we get a standard deviation equal to 3.977. If anything has gone wrong in terms of you don't have the right summations here, Check to see where the thing went wrong. Is it just I added things wrong in the calculator, or I squared something wrong but then added what I have correctly? It's just the wrong information. Fix those things up. I want you to be aware at those early steps, if a lot of mistakes are happening or if some mistakes are happening, that is something you need to pay attention to. The speed at which I'm expecting you to do these is going to increase. Okay? You're gonna, as we get more and more practice, you should become quicker and quicker at these things. So we're looking for a balance of speed and accuracy. You need to do it fast enough that you can finish in the allotted amount of time, but at the same point, you have to be accurate enough. So we're going to be working on that balance throughout the semester. Certainly first time through, slow as you need. This time through will take a while. As we get through the homework, it should be faster, and as we get through the exam, it's going to need to be faster. And by the time we're at the final, you're going to need to be going through relatively quickly. It's not going to be, let me stop and think about what the standard deviation is and how do I get there and what, you should just know by that point. You should be able to just go forward. So again, the practice will get you more confidence because you've done it multiple times. And that's what we're shooting for. Okay, so if anything that you have is off, check to see where there's a mistake. And if you can't find it, certainly email. It's always possible that I've made a mistake as well. And you guys certainly call me out on it if it does happen, but it's not supposed to. I do try to check these things, but really what ends up happening is I just type it in wrong is how it sometimes works. Excuse me. So we've got our standard deviation. Make sure you understand how to do that. If not, go back to your notes. This was a topic we covered in the first quarter. We're not going to be going through it in week 7. We're not going to be going through it in week 10. You just need to know it by that point. Okay, so we take that and we move on to the next part, which is the proportion scores. Apparently I'm not giving any relief here. So the next portion are the proportion scores. That is the P and the Q. If you know what that is, pause now and solve for it. If not, I'll give you a little bit of a description and then you can solve or pause and solve for it. So if you can do it on your own, great. Solve for P and Q. All right, if you've forgotten what P and Q are, remember that P and Q are proportion scores. P and Q really not standing for anything. So it's really a group 1 versus group 2 proportion. A proportion is how many in each of the groups account, or how much do they account for in the total number of scores available. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 scores total that fall into group 1. And cursor back 1, 2, 5, 6, 7, 8, 9, 10, 11, 12, 13 scores that fall into group 2. So we have 24 total. 11 of them fall into the first group and 13 of them fall into the second group. So P is going to be 11 divided by 24, 11 people in group 1 divided by 24 total scores. Hopefully you got the proportion of 0.548. And Q, 13 scores in group 2. 13 divided by 24 is equal to 0.542. Hopefully that is, again, simple calculation. I'm assuming you can do that, but that's what P and Q are going to be. Okay, now you notice how quickly we're going today. It's because this is just for you to double check. We went through this yesterday or in yesterday's video, and you've got your notes with you. You can use your notes to go through all this, so you should have those right with you so you can sort of see what comes next and just do it with new numbers. The step at this point is write the formula down. I always do that as step 1, but it needs to be there. And then plug all the numbers that we have just collected, plug them into the right part of the formula, and solve. All right, so pause now, do that, and then come back for the answer. All right, so we write our formula down. RPB is equal to the mean of group 1 minus mean of group 2 over standard deviation. That quantity multiplied by the square root of PQ. So, apologies, and this again. Mean of group 1, 18.18, minus mean of group 2, 18.61, divided by our standard deviation, which we solved to be 3.977. So we would solve for that. And multiply this quantity by the square root of 0.458 multiplied by 0.542. So we multiply by that, take the square root there. This is a closed parentheses. PowerPoint just cut it off, it looks like. And then multiply this quantity by that quantity and it will give you, in this case, negative 0.0537. Now, also note in terms of negatives here, we just made males group 1, or I made males group 1 and females group 2. There's no reason that had to be that way. You may have made females group 1 if you created the data set and males group 2, in which case you would have a positive value here. You still have the same numeric value. It would just be go from a negative to a positive or from a positive to a negative. So so if you do it backwards, you either rank in a different order than I do, or you have group 1 as group 2 and group 2 as group 1 as compared to how I have it. All that will happen is the positive or negative sign will change, but you just interpret it according to the way it's set up here. So we have a 5%. If we turn this into a percentile, we have a negative 5% correlation. That's going to go in the very weak side. So in terms of interpretation, which is part of the finale of this question, the fact that it is almost 0, it is that weak, means that there's really not much here. I mean, that's what close to 0 means. So here's one of the final answers. This is what I'm going to be looking for. R to identify that it's correlation, PB to identify its point biserial. The end of all those calculations ends up as this one number. In this case, negative 0.0537. Again, for correlations, I carry it out to 4, so I can turn it into percentages of people like that. Then I just have to move the decimal point over 2. And then we have the interpretation. Again, there's not really going to be much here. So I put this back up for your reference point. Move my face again. So you have that in this slide. Negative 0.01 to 0.09 is very weak. We fall into the very weak. So we have a very weak negative relationship between gender of the part-time employee and the hours they work. This is just really, again, remember from last time, this is just a restatement of this. This isn't an interpretation. It's just turning this into words. And if that is helpful for you, I encourage you to do it. It's not something you actually need to do. The second one, though, if this isn't there, then you have to include a little bit more down here. I mean, that's sort of how it works. I need the right information to do this. The conclusion is that you have a very weak correlation, close to 0. There does not appear to be any relationship between gender and hours worked. Therefore, if what I was brought in to do here was to look for gender bias, there is no evidence to suggest that there is gender bias based on this correlational sample. Okay, so something along those lines. So just on the basis of the sample we have and the fact we have a very weak correlation, there isn't anything that looks like there's a relationship between gender and number of hours worked. Okay. All right, now again, fingers crossed, you can sort of see the difference between when we go through it for the class and as we're sort of zooming through it here. This is why I said you're doing the work, so if you knew what to do, this would have been done a lot easier. If we went through this and you're like, I don't remember where any of that comes from, go back and watch the video again. That's the only, or if your notes make sense, look at your notes. But you can have those with you while we're going through this in lab. You can have that stuff with you when you're doing homework. You can't talk to somebody, but the materials for homework are going to be fine. But just make sure you're aware that on exam day, you're not going to have that information. So if you're comfortable with it, you've done it well enough and enough times that you know what to do, that's going to get you better prepared for exam day. So if I can wean you off of the notes, that's probably better. But work at whatever pace you need to work until you feel comfortable going off book at some point. Okay, so there is our point biserial. So there's a second example of the point biserial. You can follow through either one to try again. And again, you've got the data set. You can certainly just copy the data set down itself without the rest of the work and then try it again to get the correct answer. Typically, if you want more stuff, more problems to work on, there are examples in the textbook, and those have been worked out. Now, remember for point biserial, it's not in the textbook. This is the one thing that isn't in your textbook. But for everything else, the examples that are worked through in the textbook and the ones that have answers in the back of the text, the odd problems typically for a chapter, those are all extra data sets that you can work out and you have the answer to check. So please, if you need more work, it's there. I don't need to give it to you. The textbook provides examples for you to sort of work from as well. Okay, let's move into our second correlation. So problem number 2. Again, same problem. This is, it's listed on the data set itself what correlation it is. But here would be the setup. And again, notice that sometimes the data set will be larger, sometimes it's going to be smaller. Sometimes it'd be large numbers, sometimes things with decimal places, everything, because those are all possibilities. So you need to learn, am I only careless if there's decimal points? That's something that you need to know. Am I uncomfortable with large numbers? Is that where my mistakes happen? So we're going to have examples of all kinds going through here. On exam day, they're going to be smaller data sets. That's the one thing I will promise you. But for homeworks and for examples in class, they may be longer, just so you are used to working with numbers and doing the grunt portion of this. Okay, problem 2. As part of our human biology class, you're asked to see if there's a relationship between someone's age and the potential for diabetes. You collect glucose levels from your family members and conduct a correlation on the data. So the thing that you are interested in is age. So that's listed here for 6 of your family members and their glucose reading, which is right here. So both of these are at least interval or ratio. These aren't rankings. These are not nominal. So these are interval or ratio. As a consequence, because both of them are interval or ratio, you're going to go ahead and do a Pearson because that one is set up to do both of the data columns being interval or ratio. So we're doing a Pearson for this one. Again, that was given, if you looked at the data set, it says lab Pearson. Okay, so here's a Pearson. And again, look at this, and I wrote it down here because again, I'm not taking the train wheels off completely, but I am kind of yanking them away as we go along. Here's a formula. So either from the formula page that is on Canvas, or if you have a printout, or if it's on the lab sheet that you wrote on and you wrote it there, you can get from there. So we got this formula. We know we're going to have to calculate just by looking at the formula an XY column. We're going to need to sum the X column. We're going to need to sum the Y column. We're also going to need an X squared column. We're going to need to sum it. We're also going to need a Y squared column, and we're going to need to sum it. So you're going to have to create all of those columns, do the multiplication or squaring, sum everything up. Once you have all of that done, come back and check your answers. Okay, so that's how we do it. We look at what's in the formula, tells you what columns you're going to need, do whatever math is required, get to those columns, come back and check. Until then, pause the video and then come back when you're ready to check. All right, let's see how we did. Here is the data set now. So we did steps 1 and 2, summing the X and Y columns. So our sum of X column is 251. Sum of our Y column is 486. We squared both the X and the Y values and summed them up. So sum of the X squared column is 11,897. Sum of the Y squared column is 40,022. And we have the XY column, each individual value of X multiplied by value of Y. And we end up with a value of 20,809 for that. Okay. Make sure that you have all of that correct. If you have a mistake, fix it, make a note or something about what went wrong. And if you keep seeing the same note come up again and again, know that that's something that you are going to have to worry about. That's something that you're going to have to watch out for as we get to exams, but also homework. So just be aware of it. I mean, that's why we're doing this. That's why I'm having you do this. Okay, so what comes next? Well, we really solved for everything that we need. I mean, n here obviously is 6. So n in this formula is equal to the number of people, not number of scores, but each person gives 2 scores. There are 6 individual people, okay, 12 scores. N in this case is going to be equal to 6. We take everything we just have collected, write down the formula or by where that formula is at, plug all of the values in, and then solve. Okay, so that's the next step. Plug everything into the Pearson formula and go ahead and solve the Pearson formula. So pause, do that, and then come back when you have an answer. All right, let's see how that step went. So our n was 6, sum of the x, y is 20,809, sum of x 251, sum of y 486, n is 6, sum of the x squares column 11,897, sum of the x column 251, 6, sum of the y squared column 40,022, and the sum of y column 486 quantity squared. So again, solve bracket first, solve this, multiply the two of them, take the square root. I would start at the bottom. Then do the top, multiply those two together, subtract this quantity from that quantity, then divide the top, the end value of the top by the end value of the bottom, and you should have your value of R. So R is going to be showing up next. Make sure you solve for R, and you have an interpretation ready. Okay, remember that's also here. Whether I say it or not, there's supposed to be an interpretation of the data. So I'm going to expect an R, and I'm going to expect an interpretation as we go to the next slide. So go ahead and solve if you've not done so. Add the interpretation if you have not done so. Pause until then, come back, and then we'll go forward. All right, now also understand the interpretation doesn't have to be the exact wording that I have. If it's capturing the same relationship, you just say it differently, then that's going to be fine. Okay, there are different ways of writing the same response as an interpretation. Okay, so I end up with a R is equal to 0.499, so 49.9%, essentially 50% if we round it. And that's going to put us as relatively strong. I forget the wording. I don't have the chart memorized either. But we go back and see where our correlation to 50% is. And obviously if it's 50%, it's smack dab in the middle. So there's some strength there. It's not as strong as it could be. It's not as weak as it could be. So it's really the average correlation we would have. So there is a correlation. It is a positive correlation, which means that the older a person is, the higher their glucose level. But it's not a super strong one, which means it's not sort of a one-to-one connection. It is a bit messy that's going to be there. So here is the interpretation. Here's our raw answer. Me putting this into words again, there's a strong positive relationship, 49.9% between age and glucose level. So as the age of the individual increases, so does their level of glucose. The fact that I have up here, the fact that it's strong and positive means I don't have to also put it down here. Okay, if this is the only thing you put in, you're going to have to include some of this material from up here. Okay, so I split it into two sort of like little things, one that describes the number and is related to the overall interpretation, and an interpretation. But if it's presented, it means the person has read all of it. So all of that together would be a decent interpretation for them. Fingers crossed, hope that went well. If not, go back. If all the numbers are right, if all your numbers match, in here, don't spend time looking to see here. You did something wrong after I plugged it into the formula, something went wrong. So, then you would check, did I write the formula down? Did I just make any simple mistakes? So maybe write down smaller steps if that's a problem that keeps happening. But if everything is right in the table, there's no reason the final answer shouldn't be off. Again, if we're at the hundreds or thousands point and you're like 1 decimal point off, that's not a big deal. That's a rounding issue. If your rounding becomes an issue, which means you round way too early in the process and it carries through, I will let you know about that. But for the most part, if at the final answer you're off just by a little bit at like the thousandths decimal point, I don't care. That's not a big deal. That's going to happen. Okay, hope that went well. Let's move into our third. Here for problem 3, obviously, by process of elimination, we're going to be doing the Spearman row. Okay. And again, I don't leave you quite hanging. We have a cartoon animal here reminding you something. I won't tell you what it means just yet. I will just move my face out of the way. So here's our problem. At the beginning of the academic year, Mrs. Rinema, a math teacher, gives her 6th grade class a diagnostic math test. Given that there were some changes in the SOL standards the previous year, she wants to know if this math test could be used as an accurate test for diagnosis, how they'll do in the classroom. So she has SOL data from the students. Here's what she's been using as diagnostically how well it's going to do by the end of the academic year. Early on, she's checking to see if the SOL score that she is given about a student, which is supposed to be how a student is going to be doing in math, if she can use those new SOL scores to predict how they'll do on an assessment of what they're doing at the end. Okay, so she's trying to correlate. This really is sort of working towards a regression, and we're going to see that correlation and regressions are linked. We're just sort of artificially cutting it off at the correlation, and that's something that we're doing just so I don't overwhelm you already more than I'm doing. So Notice that this is rank SOL, which means the students in the classroom were ranked. These are not actual scores. Her classroom is given. She doesn't see the raw data. She just knows that this is a person with the highest score when they took the SOL, and this is a person in the classroom who's next. Now, in reality, it makes it look like the person 1 has the highest score and person 2 has the second highest score. Remember that the entire 3rd grade takes the SOLs. So the ranking is for the students she has in her class only. Of the people in her class, number 2 is the second highest of the students in the class. He may be, so person 1 may be the highest 3rd grader of everybody. And the one she has in her class is number 2 is really like the 37th overall 3rd grader. But in her class, number 2 to 36 aren't there. So it's a second rank in her class, but it doesn't really say what his math ability is. And that's why rankings are sometimes wrong. This is a ranking of students in her class based on their SOL scores. It doesn't say anything about how well they actually did. So this is why she's checking to see, is there a predictable relationship that I can use? Okay, so the SOL is rank. Math score is how many did you get right? Percentage of how many, or what percent people did. You see there's some variation here, but certainly not a big cluster. And again, even if you just eyeball the data, you know this isn't going to be a huge correlation, or it isn't likely to be a huge correlation at this point, because the data points really are kind of close together. The lowest score is 40. The highest is, looks like 77. There's some spread, but it's not like it goes from 0 to 100. Okay, so we know that it could have been larger. So we're going to have somewhere, it's a messy one in the middle somewhere. But what part of the middle is unknown. Now we're then going to have to think about something else. So Alligator here says, let's see if you remember about step 0. So I'm just going to pause it. You think about what step 0 is, and then come back. All right, if you still have no clue what step 0 is, I will tell you, and then you'll have to go on. If you did remember, congratulations. Remember with the Spearman-Rowe, if one data set comes in as ranked, we have to turn both columns into ranks. So this is, first column is ranked, so obviously this is ordinal data. Our second column is interval ratio data. Okay, again, it's actually ratio, but for us, we don't need to separate. If it's interval or ratio, same statistics are used. So as long as it's at least interval, that's all we care about. Point by serial, I'm sorry, the Spearman-Rowe requires that both columns be ordinal. So if you have a column that is still interval or ratio, step 0 is you have to now re-rank this. You have to turn this column of interval ratio data into an ordinal scale. So just as this is organized from 1 to 10, you're going to have to organize this set of columns from 1 to 10. Now, you can either use 1 as the lowest score or 1 as the highest score. It really doesn't matter. And the end result is only going to be you get a positive score versus a negative score, but the value will be the same. So it doesn't matter which way you do it, but you do have to rank it. So column 2 has to be re-ranked, and then we're not using these raw scores in column 2 ever again. So if you know that that's what you're supposed to do, go ahead and do it. If you didn't know that, circle it, make a note, put a star by it so you're aware of that if you have to do it again. But pause, turn that into its ranked data, then come back. All right, so we're going to make this transformation into ranked data. And what I've done is I've just grayed this out so we don't see it. Now, obviously on your paper, that's not going to happen. So you can still make, again, as I said, there's always an idiot column in here. You may do this right most of the way, but on one of them you use a raw score. So it's not just the subject number that can show up. You can just use the wrong column of data sometimes. And here we're looking for a different score. You do subtraction from the wrong value. Okay, that can happen as well. Okay, so we write down our formula. So again, here's a reminder, Spearman-Rowe, both columns need to be ranked, so we need to transform the scores. And this is the data we're going to be using going forward for the math score. Okay, it's been transformed. Write the formula down. Here's our formula. Remember that 6 and 1s in this formula are indeed constant, so we don't do anything with those. But we do need to have a d squared column, which means that looking at the steps, we're going to have to create a d column first. D is a difference column, x minus y. So for every value of x, subtract the corresponding value of y to give you a d score. Once those are done, you're going to have to square each of those scores to get us our d squares. And then you're going to need to sum up the d scores and get the sum total of that. And that is the thing that's going to get plugged in at this point. So create a difference column, square the values in the difference column, sum up the square of the difference column, then plug everything into the R row formula and solve. So we plug in the end of that column here at D, sum of D squared. N, of course, is number of participants. I will let you see if you can figure that out. Plug everything in and solve. Okay? And remember, we're going to have to interpret as well. Do all that, pause. In the meantime, come back when all that is finished. All right, let's see what we got going forward. And as always, no matter where the face is, it's in the wrong place. And check that up there. So here's our formula. We substitute in. So 9 minus 4 was 5, 3 minus 2 is 1, 10 minus 10 is 0. We just need the difference scores. We don't need to sum them up, but we do need to square the scores. So 5 squared is 25, 1 squared is 1. We do need to sum this column up, so we sum all of that up. Remember, the negative sign is taken away when we square. Gives us a value of 54. So 54 goes in here as the sum of the D squared column. We have 10 participants, so 10 goes here as N, and obviously 10 squared, 100 minus 1 is 99. So 99 times 10 to solve the bottom, 54 times 6 to solve the top. Take the top, divide by 990. Take that value, subtract from 1, and that should have given you an R row of 0.6727. So this is 67.27%. If there's no sign listed, that means it's positive. And we go back to that chart and see that 67% is a strong positive correlation. So that's what we're going to put down here. Again, I don't care which way you do it. You sort of combine this all together, or you have these sort of sit out as separate parts of the interpretation. I think either one is fine. But you definitely need this, the actual numeric value, and you're going to need something that interprets it somehow. However you do that is up to you. So we know there's a strong positive relationship between SOL scores and diagnostic tests, and it's a positive one, which means as the SOL score goes up, the ranking, not the raw scores, but the ranking of the scores on the math test go up. And with that relationship, the people who did well on the SOL test tend to be doing well on the math test. That means that this is something which, at least for now, you can feel comfortable using as a diagnostic test. It's not the best one. You may find better ones out there, but this is strong and positive related between the two. That means that this is possibly a test that you should feel comfortable using. Okay. All right. Hopefully that went well. If not, I kept these short so you can go back to any problem that was giving you trouble. If you need to go back to the video of sort of walking through step by step, go ahead and do that video. Then there will be a homework that is assigned for Tuesday afternoon, and from there it'll be due on Friday. Again, we'll start a new topic on Wednesday. So as I said, after we got past exam 1, things are moving at a much quicker pace. We'll hit a pause, a slowdown period in a bit, but I'm getting all the calculations out first. Then we'll go back and fill in some of the details, give you practice time before we get to an exam, and you can get feedback on the homework, etc. And exam 2 will be starting at the Z-scores and going up until I say we're done. It's going to mostly be correlations, regressions, and the Z-score stuff that we've already done. Okay, so if everything has gone great, you are ready for the homework. If things did not go great, spend time wherever you need to spend it. This video is short enough you can go back through and double check. But if you just looked at the answers, you may not know where something went wrong. So again, I hope you did the work for this. All right, that is it for the video portion of the lab, and now you've got the rest of the lab to work on the homework if you are ready for it. All right, thank y'all.